Subtopic 3.2 Binomial expansion. Definition of n factorial. If n is element to positive integer, then n factorial is given by n factorial equal to n times n minus 1 times n minus 2 times n minus 3 until 2 times 1, where 0 factorial is equals to 1, 1 factorial equals to 1. Note that n factorial equals to n times n minus 1 factorial. N factorial equals to n times n minus 1 times n minus 2 factorial. Example 1. 5 factorial is equal to 5 times 4 times 3 times 2 times 1, and the answer is 120. 8 factorial over 6 factorial is equals to 8 times 7 times 6 factorial over 6 factorial. So we can simplify for 6 factorial and the answer is 56. 20 factorial over 5 factorial, 16 factorial. Try to answer this question and the answer is 969. Example 2. Simplify for n plus 2 factorial over n minus 1 factorial. N plus 2 factorial is equals to n plus 2 times n plus 1 times n minus 1 factorial over n minus 1 factorial. Simplify for n minus 1 factorial and the answer is n times n plus 1 times n plus 2. Simplify for n plus 2 factorial over n factorial. N plus 2 factorial is equals to n plus 2 times n plus 2 minus 1, so become n plus 1 times n factorial over n factorial. N factorial you can simplify and the answer is n plus 2 times n plus 1. Definition of a binomial coefficient. Let n and r be non-negative integers. For 0 less or equals than r less or equals than n r is equals to n CR equals to n factorial over r factorial n minus r factorial. Example 3. Evaluate 5(2) equal to 5C2 equals to 5 factorial over 2 factorial 3 factorial, and the answer is 10. 4(0) equals to 4 factorial over 0 factorial 4 factorial, and the answer is 1. You can use your calculator to calculate 4C0. Expansion of a plus b to the power of n. Look at the pattern. The arrangement of numbers is called Pascal's triangle. Binomial theorem. For n a positive integer, from Pascal triangle, a plus b to the power of n equal to n0 a to the power of n b to the power of 0 plus n1 a to the power of n minus 1 b to the power of 1 plus n2 a to the power of n minus 2 b to the power of 2 plus until plus n a to the power of 0 b to the power of n is equal to a to the power of n plus n over 1 factorial a to the power of n minus 1 b to the power of 1 plus n minus 1 over 2 factorial a to the power of n minus 2 b to the power of 2 plus until plus b to the power of n. From binomial theorem, the power of A decreases by 1 for each term from left to right. The power of B increases by 1 for each term from left to right. The sum of the powers of A and B always add up to n in each terms. The expansion has n plus 1 terms. TR is equal to nr minus 1 a to the power of n minus in bracket r minus 1 b to the power of r minus 1. Or you can use t r plus 1 equals to nr a to the power of n minus r b to the power of r. For binomial theorem, if a is equals to 1, a plus b to the power of n, substitute into binomial theorem, simplify, and the answer is equals to 1 plus n over 1 factorial b to the power of 1 plus n minus 1 over 2 factorial b to the power of 2 plus until plus b to the power of n. Note that for n positive integer, no need to show n0, n1 or n2 because the value can be evaluated by using the calculator. But for n non-positive integers, fraction or rational numbers, n0, n1 or n2 cannot be found by using the calculator. Example 1. Use the binomial theorem to expand the following. A. 4 plus x to the power of 3. B. 2x minus y to the power of 4. 4 plus x to the power of 3. Since n is positive integer, n is equals to 3, substitute into binomial theorem, simplify, and the answer is 64 plus 48x plus 12x to the power of 2 plus x to the power of 3. 2x minus y to the power of 4. By comparing with a plus b to the power of n, a is equals to 2x, b is equals to negative y, and n is equals to 4. Since n is positive integer, substitute into binomial theorem, simplify, and the answer is 16x to the power of 4 minus 32x to the power of 3y plus 24x to the power of 2 y to the power of 2 minus 8xy to the power of 3 plus y to the power of 4. Example 2. Write down the first three terms of the following binomial expansion in ascending power of x. A. 3 minus x to the power of 5. B. 4 minus x to the power of 6. C. 1 minus 3x to the power of 5. 3 minus x to the power of 5. By comparing with a plus b to the power of n, a is equals to 3, b is equals to negative x, and n is equals to 5. Since n is positive integer, substitute into binomial theorem formula and simplify. The answer is 243 minus 405x plus 270x to the power of 2 plus dot dot dot. 4 minus x to the power of 6. N is positive integer. N is equals to 6. Substitute into binomial theorem and the answer is 4096 minus 6144x plus 3840x to the power of 2 plus dot dot dot. 1 minus 3x to the power of 5. Try to substitute into binomial theorem and the answer is 1 minus 15x plus 90x to the power of 2 plus dot dot dot. Example 3. Expand 1 plus x to the power of 10 up to the term in x to the power of 3. Find the value of 1.01 to the power of 10 and 0.99 to the power of 10. 1 plus x to the power of 10. N is equals to 10. N is positive integer. Substitute into binomial theorem. Simplify, and the answer is 1 plus 10x plus 45x to the power of 2 plus 120x to the power of 3 plus dot dot dot. 1.01 to the power of 10 is equals to 1 plus 0.01 to the power of 10. By comparing with 1 plus x to the power of 10, x is equal to 0.01. Substitute x equals to 0.01 into expansion. Simplify, and the answer is 1.10462 equals to 1.10 correct to 3 significant figures. 0.99 to the power of 10 is equals to 1 plus in bracket negative 0.01 to the power of 10. By comparing with 1 plus x to the power of 10, x is equals to negative 0.01. Substitute x equals to negative 0.01 into expansion. Simplify, and the answer is 0.90438 equals to 0.904 correct to 3 significant figures. Example 4. Expand 1 plus x over 5 to the power of 6 in ascending powers of x. Use the first 4 terms of the expansion to find 1.01 to the power of 6 correct to 4 decimal places. 1 plus x over 5 to the power of 6. By comparing with 1 plus b to the power of n, b is equals to x over 5 and n is equals to 6. Since n is positive integer, substitute into binomial theorem. Simplify, and the first 4 terms are 1 plus 6 over 5x plus 3 over 5x to the power of 2 plus 4 over 25x to the power of 3 plus dot dot dot. To find 1.01 to the power of 6 by using expansion of 1 plus x over 5 to the power of 6, we know that 1.01 to the power of 6 is equals to 1 plus 0.01 to the power of 6. By comparing with 1 plus x over 5 to the power of 6, x is equal to 0.05. Substitute into expansion, simplify, and the answer is 1.0615 correct to 4 decimal places.